Okay, sorry about that. Must hit the stop recording option there. So we're going to want to start with our givens. And so we've got two givens there. AC is congruent to BC, and AD is congruent to BD. Those are both given. Make sure that you're taking this as a chance to mark them on the picture as you write them down. And then we still have to look for a third thing, and this is a fairly common third thing, is to look for any shared sides between them. Almost all of these quadrilateral ones are going to have that shared side. So CD is congruent to CD, same segment. Then from there, we say that the triangles are congruent. So we've got the triangle ACD is congruent to triangle BCD. In this case, that is SSS, because we've got the three pairs of congruent sides. Now, when we go to use CPCTC, we do want to think about what we're trying to prove. Our job is to prove that CD bisects angle ACB. So that's this angle up here. We want to prove that it's split exactly in half. So we're proving that this angle here is congruent to this angle here. And that's exactly what we're going to say. ACD angle ACD is congruent to angle BCD. That is our CPCTC. And then because those angles are equal, that's how we know that CD bisects angle ACB. That's the definition of bisect. So what you should be looking out for here is the fact that this entire thing, this first step, except for this very last thing, was just exactly what we did in chapter 4. It's finding those three things that you know are true, using those three things to prove that the triangles are congruent, and then using CPCTC to talk about the congruent parts. The only new step here is we had something else to add on to the end of it. And in this case, the fact that this thing was talked about as a dart or a quadrilateral doesn't really affect us at all. You'll see in the next one, there are some that you're going to have to know some things about quadrilaterals, parallelograms, rectangles, rhombuses, whatever, to be able to do. So let's take a look at the harder one here. And then from there, I'll give you the practice to do. So in this case, we are proving a conjecture that we have. And that conjecture says that if the diagonals of a parallelogram are congruent, then it is a rectangle. And so that's something we think is true. We're going to prove that it's true. And so our givens here are that this thing is a parallelogram and that it has congruent diagonals. Now, it would be a great idea to start off by writing those givens down. Even though we're going to use that working backwards strategy here, doesn't mean that starting at the givens or writing the givens down first isn't a good idea. So we might write down that BEAR is a parallelogram, and that is given. And we might also write that BA is congruent to ER. You have to pardon my lack of being able to write a congruent symbol. My pen is deciding not to work. So we've got our two givens written down. And this is a point where I probably am going to suggest that you go to the end and think about what we're trying to prove. We are trying to prove that this thing is a rectangle. And so before we can do that, we need to think about what makes a rectangle a rectangle. So I'm going to just copy that. And we'll put it at the bottom here so we can talk about it. So our goal is to be able to say that BEAR is a rectangle. And the way we're going to know that that is true is by knowing that a rectangle has 4 equal angles. And so instead of thinking about proving about 4 equal angles, we can shorten that up and think about, well, every parallelogram has opposite angles congruent. What rectangles have special is that consecutive angles, this one and this one, are congruent. And so we might want to be able to say, as part of our step here, that angle RBE is congruent to angle AEB. If we can show that that is true, then we can show that it is a rectangle. And if we're thinking about that, that is going to help us with which two triangles we want to talk about. We need to pick two triangles that have one of those angles in one of them and one of those angles in the other, and they have to be congruent to each other. And really, that only gives us now one choice. This triangle here has the angle on the right, and this triangle here has the angle on the left. So those are going to be the two triangles that I want to prove are congruent. So that is actually going to be my step up here. Triangle RBE is congruent to triangle AEB. And now I can look at how would I prove that that is true. That's going to be my goal. And so if I go back up and take a look at my givens, I'm going to scooch this all up just a bit. It's a little bit too far down. So I've got one of my congruent sides there. Those are the ones that go across like that. So that would be this one and this one. Now, other ones I have are BE. I can count BE congruent to itself because it's a same segment. So BE is equal to BE. That is the same segment. And now this last one is going to come from the fact that this is a parallelogram. There's a lot of things that we learned about parallelograms in the last section. 4 of them exactly. We know that opposite angles are congruent. We know that opposite sides are congruent. Consecutive angles are supplementary, and the diagonals bisect each other. There's one of those that's going to help us, and it's the opposite sides are congruent. So we know that BR is congruent to AE. And that's just because this thing is a parallelogram, and that is something that we know is true about all parallelograms. So we're going to add that in. RB is congruent to AE, and I'm just going to put that that is a property of parallelograms as my reason. That is coming directly from the fact that it is a parallelogram, and then those 3 things together tell me that the triangles are congruent. Now I just need to go back and fill in my reasons. I have talked about 3 different pairs of sides. So this one is side, side, side. After I know the triangles are congruent, I know the angles are congruent by CPCTC. And bear is a rectangle. That is the definition of rectangle. I just used the fact that a rectangle has congruent angles to explain why it's a rectangle. So on this page, what you're seeing here is the basic part of this proof is the same as everything we've been doing. If I look at this part right here, that could have very easily been a proof that we talked about in chapter 4, except for the fact that I would have had to give you this as one of the givens instead of this. You, in this case, just had to know that because something is a parallelogram, that means that the opposite sides are equal. So you've got to know those properties of all your different shapes. And then at the end, you had to know the definition of a rectangle to be able to prove that this thing is actually a rectangle. That's the new part. This stuff is still there. Now, the best part about this is that this being a standard in chapter 5, which contains this part here that was a standard in chapter 4, is going to let me do something very nice. If you can show me that you've learned this part in the middle here better than you knew it in chapter 4, there's no reason your grade shouldn't go up for that. So this is going to give you a chance without even retaking the chapter 4 test to still improve your chapter 4 score if this proof stuff was not one of your strong suits. So that's going to be a great thing for a few of you that could really use that one standard to go up without actually retaking this whole test. So that is basically it. We also spent some time in class going over the quiz, but I think if any of you have sent me that quiz already by the time of making this, I believe I've sent you back some feedback on which ones you've gotten right or wrong. So that's nice. And then you've got your practice here. It's page 301, 2 through 5, and 9. Tomorrow, the plan in in-person class is not going to be to do a whole new section. We're actually spending tomorrow on this same section. And so there's probably not going to be a new video tomorrow. But what is going to be super important is that you take these questions that you have, you actually try these out, and that you're asking about them. We're doing, some pretty hard things here. It's a little bit more tricky than some of the stuff you've done in the past. So make sure that you're asking questions. One thing that I'm going to tell you right now that's going to help, number 2 and number 4 are the exactly opposite of each other. So a lot of the steps in number 2, if you just take them and go backwards, are going to help you out in number 4, just so that you can kind of think about that. Number 9 here. This is a good one. We've done this proof already. We haven't called it an isosceles trapezoid yet, so really need to think about, what does a trapezoid mean? Because that's what's going to help you. Using the definition of a trapezoid to help you with this proof, because I think we've already done this one. Just I told you what trapezoid meant instead of used the word trapezoid. So start that homework. Make sure you're asking questions. This is the hardest section in the chapter, so you definitely want to be getting some feedback on how you're doing on these. And I will have a new video for you, I believe, on Wednesday with our last section of the chapter.